the integral calculus. Integral calculus. Uh, uh, in fact, last two classes I am talking about integral calculus, and I have discussed with you that integration is divided in two parts: indefinite integration and definite integration. Indefinite integration, as the name itself gives you an idea, it tells you about when the integration is performed without limit. And the second part is definite integration, that is when the integration is performed with limit.
So you are not audible.
Hello? Hello? Yes.
Yes, sir, your voice is coming.
Okay. So integration is the process of joining small elements to get the large one. This is a starting note which I already discussed. Today, if you recall, last class, I have given you one numerical problem. And by and large, it is clear to all of you that how to integrate a function. Okay. And one numerical problem which is related to business organization, I have discussed it. Today, I would like to shift your focus and I would like to move to the second half of the integration that is known as definite integration. So I'm opening my Word file so that I will be in a better position to discuss it with you. Is my Word file is visible? Blank file is visible to you?
Yes, sir.
Yes, it is.
Okay, I'm coming with that. So I'm talking about integration. Okay. And I have discussed with you that we have two types of integration: indefinite,
जी सर
indefinite, and then we have definite. Okay. This is what I wish to focus on. Okay. What is indefinite? When the limits are not given. Limits are not given. Limits are not given. Limits are not given. When the limits are not given, we call it as indefinite integration. The opposite of that we have the when the limits are given to us. When the limits are given. Limits are given. And the limits are given. This is what we have. Okay. Now, what does this mean? Limits are given, limits are not given. That would I would like to discuss it with you. So this is the symbolic representation that we have already discussed with you, right? Now, if we have fx any function fx and we take it dx, this is we call it as indefinite integration. Indefinite. This is indefinite. Why do I call it as indefinite? The reason is that there is no mentioning of lower limit and the upper limit. If you see the symbol, down we have lower limit. If I write it down here, so we have lower limit and the upper limit. We call it as this as an indefinite integration. But if I insert the limits, like I would show you what I mean to say when I'm saying the limits. somewhere we have that symbol. Just 1 minute. Okay, so I've just using actually this one. We have equations, and then we have this. So if I write this as 3, if I write this as -1, and I will write right here this as f. Is this visible to all of you?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
So this is what we have. Actually, what I would like to share it with you is this, that by definite integration, I mean to say this, where I inserted the lower limit -1 and the upper limit as 3, and then we have the integration fx dx. So the difference between indefinite and definite is clear with the help of this expression, I hope, right? So today I would like to focus your attention on this part. We call it as the definite integration. In the definite integration, the only difference here is that we just put it like this one equal to this, and when we integrate, suppose this is the integration f, so we put it the upper limit first f3, then we put the minus sign of subtraction, and then we have f, and then we have -1. So what we need to do here is that if we have a function fx, we integrate it, and then we put the upper limit, and then we put the lower limit. For example, I will just take it as fx